Hello everyone, welcome back to our channel. So today we'll be solving some questions on the K nearest classifier or the K nearest neighbor classifier. So let's get started. So this is the first question that we are going to solve today. So what question says is, the figure 1 illustrates decision boundaries of two nearest neighbor classifiers. Determine which one of the boundaries belong to the one nearest neighbor classifier and which one belongs to the three nearest neighbor classifier. Okay, so they are saying that there are two decision boundaries that they have given, and one of them belongs to 1 NN or one nearest neighbor classifier, and the other one belongs to the nearest neighbor classifier, and we have to identify which one belongs to which. Okay, so we have to find 1 NN and 3 NN. Okay, so this question is slightly ambiguous because they should have given that what is the distance metric, and usually we use distance as Euclidean, so we'll assume that we are using Euclidean distance here. Okay, so now let's understand how the Euclidean decision boundary looks like. Suppose you have these data points. Okay, I'm talking about only 1 NN classifier here, and that will be sufficient to solve the question. Okay, so how the 1 NN decision boundary looks like for this data, assuming you are using Euclidean distance metric. So for this, what we do is we join the points, the line joining to them, and we take a perpendicular bisector to this. So perpendicular bisector is nothing but a line that divides this line into two equal parts and also is perpendicular to it. Okay, so we'll do this with all the 3 points, and we'll create the perpendicular intersector to these, and we created it like this. So in 1 NN, what we are doing is so in 1 NN, suppose a point is here. Okay, so basically I'm giving you intuition like why we do it like this. So suppose a point is here. Okay, now this is at equal distance. If we take the Euclidean distance, it's at equal distance from this negative point and equal distance from this positive point. Suppose, but if you take any point to the right of this, it will be very near to the negative point compared to compared to the distance to the positive point. Okay, so that's why there is a decision boundary coming over here, that is saying that okay, beyond this it will be closer to negative point, so the classification will be according to the negative point. If any of the data point falls here, then we are saying that this is closer to the positive point when compared to the negative point. So every data point which will be here will be classified positive. Okay, so this decision boundary is like this. Similarly, here if you see, every point which is beyond this line will be classified positive, and everything which is beyond this line will be classified negative. And so compared to these 2 points, so every point that will be here will be classified according to this point, which is positive, so it doesn't matter, classified according to this. And if suppose my points were lying here, they'll be classified according to this point. Okay, so these will be classified accordingly. Okay, so I think I have made a lot of mess here, so let me just reconstruct this. So I had 3 points, positive, and negative. Okay, and the decision boundary I got was, so here is my decision boundary. Okay, such that there the distance between the 2 points, we are taking a perpendicular bisector between that line which is joining these 2 points, and that's how we are marking this decision boundary. If we had just this data, suppose we had this plane, we would have just marked it like this. Okay, so every data which would have been here would be classified positive, every data which was here would have been classified positive, and every data here would be classified as negative. Okay, so with this knowledge, can we solve this question? So you can see that negative point has a boundary around it, and so for example, now let's try to find whether we are able to find the perpendicular bisectors. So if I join these two, this is the perpendicular bisector. If I join these two, this is the perpendicular bisector. If I join these two, this is the perpendicular bisector. If I join these two, this is the perpendicular bisector, and so on, right? So this particular graph belongs to 1NN. Okay. Now let's talk about 3NN. So 3NN is slightly difficult to visualize and construct, but we can get an intuition for that. Okay. So see here, the decision boundary was separating this area because it was 1NN. So we were saying that all the points which are here will be negative. Now in 3NN, I'll compare 3 data points together, right? So in this area, suppose in this area, there is a data point. Suppose this is a data point, okay? So it will take 3 nearest neighbors to it. Maybe these two will come, and this, right? So this will be classified as positive, right? So any of the points that are falling here, beyond basically here, are being classified positive. So it's actually comparing more than one neighbors in doing this. So this is a slight intuition behind how you can see that, okay, it's considering not just one single point and multiple points, and hence it should be a 3NN. Okay. So yeah, so this is the answer, that this belongs to 1NN and this belongs to 3NN. Now let's move on to the next question. So this question is asking which of the following are true for K nearest neighbor classifier algorithm, okay, or K nearest neighbor algorithm. So it's a MSQ kind of a question, which is multi-select question. Okay, so all those which are true, we have to mark them. Fine. So let's read the first statement. So they are saying KNN can be used for both classification and regression. So this is true, right? So for classification, what we do is we take a max vote kind of a thing for predicting it to class. And for regression, we take metrics like median or average or mean, which is called, to do the regression values, right? So this is correct. A is correct, that KNN can be used for both classification and regression. Now they're saying as K increases, the bias usually increases. So this we had seen in the previous video, that as K is equals to N, the variance becomes 0. Variance becomes 0 because all it learns, if it's a classifier, it learn max vote of all points, of all training points. Training. See, I should do it like this. Max vote of all training points. Okay. But if it's a, suppose it's a regression model, it'll just, if you are using say average metric, it'll just learn average of all training points. Right? So it's a very simplified model. And a very simplified model which does not pay attention to the training data, has high bias. Okay, a simplified model a high bias model does not pay attention to training data. This we had seen in the previous video. I will link that video in the description box to training data. Okay, so coming back to the question, they're saying as k increases, the bias usually increases. This is also correct, because when k is equals to n is all the training samples in the training data, the variance becomes 0 and bias also increases, because the classifier is not at all paying attention to all the data points. So this is correct. The decision boundary looks smoother with smaller values of k. Okay, so this is clearly not right. So in the previous question itself, you can see that this boundary looks smoother when we have more data points or more neighbors in consideration rather than 1 and n, or when there are smaller number of data points, right? So this is not true. As k increases, the variance usually increases. So this is also not true, because we just saw that when k becomes n, then variance becomes 0, because we just learned one value, a very simple function. So variance also does not become or does not increase, right? So only A and B are correct in this. So the answers are A and B. Okay. Now let's solve one more question. Given the following label data set, for what minimal value of k will the query point question mark be a negative? Enter 0 if this is impossible. Ties are broken at random. Try to avoid them. Okay. So they have given us a very good question. They are saying that you are given this data set and tell us for what value of k will this become negatively labeled. Okay, let's try to solve that. Right. So this is the data set. Okay, so let's take the example of 1NN. I will select this. This here. Okay, correct. Now let's look at 1NN classifier. Okay, so when we are looking at 1NN, suppose this point, it will look at the nearest neighbor of this data point, right? So when it's looking at the nearest neighbor of this data point, so it either will be this or this, right? And both of them are positive. So we can see if we are using Euclidean distance, this is the least. We can visualize this like this is the nearest one, right? So if we do that, then this data point is being labeled as positive, right? I will actually mark these so we can tell which is the nearest neighbor. E, F and G. Okay, so let me erase this. One nearest neighbor, right? So nearest neighbor of question mark is equals to A, so we'll label it as positive. Fine. So this is not solving our point. Now let's try to look at 2NN. 2NN is equals to, so nearest two neighbors of question mark we have to find. So we know that one of them is A and the other one we can clearly visualize as C. Okay. Now we'll take the max vote, and so both of them are positive. This is positive, this is positive. So this is giving positive. Okay, but we are looking for a negative value. So this is also not the answer. Now let's take 3NN. Okay, so we have to do 3NN of question mark. So we know that A, which is positive, is a neighbor. C, which is positive, is a neighbor. I think then B is the nearest neighbor, which is also positive. We take max vote, right? So the nearest neighbor to this are this now, right? So we take max vote, and this also gives us positive. This is also not what we were looking for. So let's do 4NN. Okay, so 4NN of question mark we have to do, which is A, which is positive, C, which is positive, B, which is positive. And now if I move to the right, I can see D is more closer, so D, which is negative. Okay, but I still take the max vote. So this is negative, sorry, this is positive still. Okay, so this is also not solving our purpose. Now let's take the 5NN. So in 5NN, what we do is 5NN of question mark, which is A, which is positive, C, which is positive, B, which is positive, then we are taking D, which is negative, and then we can see probably G is more closer, right? So G is also negative. So max vote will give positive again, which is also something that we don't want. So 5NN is also not solving our purpose. So now 6NN, we have to do 6NN of question mark will do. We'll again do A positive, C positive, B positive, D negative, and E is also negative. G negative, and now we have E negative, right? Now we are in a tie situation. If we take max vote, we don't know what will happen, right? So what the question is saying, ties are broken at random, try to avoid them. So they are saying that you can break these ties at random, try to avoid them. So let's ignore this, right? But if that's not specified, what is the value to break tie with, we will just ignore this. Or you can take anything at random, so maybe it will be like positive, right? Okay, now let's come to 7NN. I'll do the 7NN here. 7NN of question mark is equals to A, which is positive, C, which is positive, B, which is positive, D, which is negative, C, which is negative, and E, which is negative, and F, which is negative, right? So now if I take the max vote, I'm for sure getting negative, right? So K is equals to 7. So actually K can also be 6 if they specify how specifically to break the tie. And if they say, for example, break tie in favor of negative, tie in favor of positive, say for example, so then the value will be 7. And if they don't specify, then we go on till we definitely know that the classification is going to be negative. Okay, so let's look at the solution. The answer is 7. Okay. Yeah, so that's all I wanted to cover today. We'll see you in the next video. Thank you.